So, all right, I think I think it's going. All right. Hey. So that was my talk. How to set up So I know I've told some of the folks, like the organizers and stuff of js.la, about kind of like how I felt about kind of like starting this group and the reason why we had done it a long time ago. And it was actually a long time ago, like 5 years. I mean, that's a really long time. And it's a lot longer than I and Mike and Carlo and David, had thought it would last. And part of the kind of like the tenets and things when we were thinking about it was that we wanted something that was very, very consistent. And Los Angeles really, really needed that because we had a lot of, at that time, there were a lot of user groups, but they were like, you go and there'd be like 3 people arguing about active record or Ruby or whatever, like how PHP is dumb. And I was like, dude, I'm making all my money making PHP sites. I don't know what you're talking about. It's awesome. So I was like, we just need a place where we can come and talk about the things that excite us and that really gets us kind of amped up. And for me, in particular, JavaScript is really kind of that technology or that language that can bring a lot of different folks and a lot of different perspectives together in kind of one place. And JS.la is really kind of a manifestation of like all of our efforts and our desires for what we wanted to see in a community and be around kind of other people and make a space for that. So big ups to David. He's been doing this for a long time, very consistent. Yeah. Omar, I somehow roped him into this and he's still doing it. It's awesome. All the videos, things you can go back in time and see. I couldn't believe it looking back at all the videos, like, man, it's crazy. All right. Sorry, I have been fighting a little bit of a cold. So, a little bit of a side note. I'm going to talk about things kind of from my perspective, or just like how they are in my kind of warped head. I'm not suggesting any type of causality. I'm not giving you guys a history lesson that has any basis in fact outside of my own brain. Okay, so David asked me if I could come and give a talk, and there were a lot of kind of conversations that I'd seen kind of coming across my Twitter feeds and in my lunch conversations with coworkers and stuff. And in particular, I was kind of lamenting the fact that it's really hard in a large organization that's software and engineering oriented to get solid JavaScript people, solid front-end engineers kind of in the door, right? And there's a big variety of kind of reasons for that, but JavaScript tends to get this, I think, a little bit of a bad rap. Yeah. So really, what I'm not really talking about unicorns per se. I actually don't know that much about unicorns. So I know a lot about dogs. I'm not going to talk about dogs either. And really, I'm not going to talk about JavaScript so much either. It's more about how the things that you learn while doing JavaScript actually apply to other disciplines, other languages, other coding practices, other product spaces, and things like that. So really, this is like the slide that people put up here to say like, hey, I'm qualified to like tell you about all these things. This is my slide saying I'm not qualified to talk about any of the things that I said I would. So like, what am I actually talking about? And what do I mean when I say unicorns? A long time ago, before JS.la had started, a startup I worked for had kind of like crashed and burned really hard, and I was doing a lot of kind of job interviews and talking to accelerators and contractors and like trying to find a new gig. And I was talking to this one guy who ran a very large consultancy, and he's like, okay, so what are you good at? And I was like, well, I can write some JavaScript, I guess. And I know a little bit of product design, and I have a design background, and like basically it was like all of these things. And he's like, whoa, you're a unicorn. Like no one could do all that stuff. And I'm like, actually, yeah, kind of can. Some of them I don't really like to do, but yeah. So it's like when you think about your career trajectory, and I think especially if you're a JavaScript developer, right? We don't always get to choose the application space or the domain space that we're working in. It's just like, hey, you have to get this thing to work in a browser, and like, you know, IE or whatever. And like, we don't necessarily make those decisions, right? That kind of comes from other places. But as kind of a result of that, we get to experience a lot of kind of complexities and problems and things that you don't get in other languages. So if you're a systems programmer, say, and you're doing C++ stuff, you're going to be using a pretty hardened set of tools and things like that. You're not going to have this kind of unpredictability when you're moving between platforms and things, as long as you can get your compiler and linker working correctly. So there tends to be some thematic kind of biases coming from individuals who disciplines focus on isolated systems or problem spaces. So if you're writing network applications in Go, for instance, and that's all you do, and you don't really have any experience with JavaScript, your perception or your view of JavaScript and JavaScript developers and the JavaScript community is going to be probably not as positive as like we all have here. So I'm not trying to like say, this is like an us versus them kind of thing or anything like that. But there is some stuff that I think, there is some funny business in JavaScript for sure, right? But that funny business is what makes, I think, our job a lot better and actually prepares us to do work in other application domains, other problem spaces, other engineering spaces that other folks don't necessarily get access to. Okay, so when I say unicorns, what I actually mean are you folks building software and all the things that you're making in JavaScript. And specifically what I mean by that is that we tend to work in very cross-discipline ways, and that's inherently part of what it means to be doing JavaScript kind of in the first place. So I don't actually mean hackers, and I don't actually mean JavaScript. What I mean is, I gave it away. I don't mean unicorns. I mean hackers. And I don't mean JavaScript. I mean cross-discipline. And specifically, when I say cross-discipline, I mean user experience, UI, right? But also, there's a whole other set of problem spaces, like the presenters who just gave a talk before, where you start pushing into other boundaries of other types of disciplines, right? You start thinking about networking and data storage and microservices, right? And I don't think there are a lot of other languages that you can work in that actually gives you as much surface area or exposure to other disciplines that you could be working in. And so really, I mean kind of cross-disciplinary hackers. And I don't mean like the evil kind of hacker person, but like, the good kind of hacker. When I think about what a hacker is, it is someone who's very, very excited to impart knowledge upon you about the things that they are excited about. Sometimes it's about computers, but not always, right? You should see the coffee situation at work. It's like, there's some serious wizardry going on there. And if you ask anyone walking by how to work the really expensive espresso machine, like people are like very happy to like help you out, and they'll like ask you the weirdest questions just to figure out what temperature to like kind of set the thing at. Like that's what I mean by hackers, right? It's these folks that are excited about it. It's people like Mike Matuzak, who is a founder here, and like I'm sure you guys have seen his talk or seen him talk about his Nintendo JS, hacking and stuff. Like he built an assembler in JavaScript just to figure out how to make bits fly around on a physical Nintendo. Like it's more of a mentality, right, than a kind of skill set, right? And these are folks. When I think of hackers, I don't think of like criminals or spammers or like Russian botnets or whatever. But it's more like the mentality of getting excited about something and then jumping into it all the way. Hey, all right. So this is what I meant, hacker. Not that hacker, this kind of hacker. This is a really good book. You should read it. Cool. And we already talked about cross-discipline. Yeah. So, I already talked about how JavaScript's kind of everywhere and gives us exposure to different disciplines and things like that. The pervasiveness of JavaScript lets us get it really, really close to design in ways that a lot of engineers don't really have access to. If you think about folks, building the server-side applications at Amazon or something, it's pretty rare that they come in contact with UX or research. If you're working at a company like Headspace, I would assume just from the size of it that you actually have UX folks, UX researchers, product design, product development, people that you're working with. So really there's kind of the computer space of cross-discipline work, and then there's the UX space. And there's one kind of close cousin to those two that is, it is rapid prototyping and product development. And when I say product development, I mean it's a kind of thing that accelerators and incubators tend to do, or larger companies that are testing new products in different markets. You want to build something very, very quickly that's real, that you can put in users' hands, see if it works or if it doesn't work. And a lot of times that application or that thing that you're testing gets thrown out and deleted. But what that does is it provides an immense amount of value for the company that you're working for. And it says like, oh yeah, this was a good idea or this was a bad idea, and then allows you to jump forward. And JavaScript, I think, is really well positioned to enable some of these things, especially when you start looking at things like NPM, which is the largest package thing around, right? It like surpassed Maven like years ago. So there's a lot of complexities in the code and the work and things like that we try to do. Hey, all right. Complexities. All right. So there's a lot of really hard stuff that we tend to come into contact with. Both just like JavaScript's kind of weird, and there's a lot of stuff we have to work with there. And then our product spaces, our domain spaces are hard. All our products tend to be different. They have different markets and things like that we care about. The UX is probably always trying to do something crazy that looks native that you need it to work or whatever. But then when you think about the server-side stuff, when it comes to Node.js and all the other things that are kind of going on, there's a large set of things that are changing right now. So you think about the advent of mobile, increased connectivity. So you think about IoT devices and the explosion or implosion of data centers. So we have cloud services and things that are just kind of more on demand that we can start up. And we need tooling and ways to interact with these like virtual servers as they kind of come up and down. So this kind of movement around mobile, increased connectivity, cloud services, user expectations kind of manifests a new and evolving computing environment. And JavaScript folks tend to be kind of at the forefront of this. And if we think about some of the responses to this changing behavior, some very concrete examples are like stateless REST API design, microservices. You think about continuous deployment, dynamic loading. In your front-end applications, that's you download a little bit of code to get it working, and then you kind of download everything else on the fly. This is a response to the need for providing your users with very responsive user interfaces and not blocking forever. Or if you're delivering to people in Brazil or wherever, you don't want to be sending these giant bundled JSON things down there, right? It has to be a little bit at a time. Key value stores, so Mongo, Couch, all these things are strongly rooted in the JavaScript community, as well as the offline first kind of approach to development. IoT and robotics to me is fascinating. It's really interesting to see JavaScript kind of come online there, right? And you can start, without being a hardcore systems developer, like you can install Johnny 5 and like plug in some switches and like you're kind of off to the races, which is really exciting. And you didn't have to like install a C++ compiler or anything like that. So if we think about kind of first principle things when we're creating our applications on the web platform, there's kind of a bunch of questions I think you can kind of ask yourself when you're building your application. You say, like, how does my application even get to the user? Like, what is the browser doing? What technologies do I need to do to realize my UX design? Whether you're using frameworks or not for all that stuff, like all of this technology needs to be plumbed together and someone needs to do it. And it's really good if you, as a developer, kind of like gluing all this stuff together to kind of understand the problem space and what these tools are affording you as you're kind of putting this stuff together. In Node.js, it's a little bit different story than you would have in the browser because there is no UI, right? But in particular, Node.js, I know for a lot of folks in this room, and myself included, was a really good way for front-end engineers to kind of propel themselves into other disciplines and even other careers. I've seen folks that were doing front-end JavaScript, end up doing like nothing but DevOps now, just because like that they discovered that they figured out they could do it with Node.js, and now they're just doing it in a bunch of different languages. It's not even JavaScript, but it really kind of opened up the realm of possibilities for them because they had this this non-blocking thing that kind of had similar POSIX-like APIs that made it really understandable for them when they started looking at C APIs and more low-level systems thing. If we think about the complexity when you're putting together a Node.js app, you're building a server. For that server, if you're just like putting something together on your machine, like localhost, and run it, it's not going to be very useful unless you hook it up to something, right? Like it needs to hook up to a database or some kind of messaging service or some kind of pub/sub thing. You're probably going to build a bunch of different microservices. Whatever's managing those microservices is probably going to be written in JavaScript, just because like a lot of this tooling and stuff is. And your microservices themselves might be just tiny Node.js processes that you're running. So that's kind of a lot of stuff, right? It's just like JavaScript covers like kind of a lot of ground, and there's a lot of surface area to kind of dive in and see, kind of what's up in other disciplines. I was talking a little bit before about how JS has some negative biases, and people, don't see it in like the kindest light or whatever. It's just like, it's not correct or a good choice in particular circumstances. And I think this sentiment is actually changing, and we're starting to see JavaScript taught in universities and things now. Like I know Stanford is, having a lot more JavaScript classes in their traditional CS curriculum, which is really nice. But I would say like none of that stuff really matters because it doesn't have to be correct to be fun, right? JavaScript's pervasive already, and it's really close to end users. So there's some really good properties to learning this stuff. Have you guys, does everyone know what this is referencing? Does anyone not know what this is referencing? Okay, cool. So there's this really old book. It's not that old, but it's less than 200 pages, and in the foreword it extols the very few virtues of that are isolated from the horrendous features of JavaScript. And it's really kind of it's a set of, I guess, best practices or good practices to kind of work around, what's bad in JavaScript or what the author perceives as bad in JavaScript. But my counter to that is if you look at it and you look at what's bad about JavaScript or what people claim is weird or not cool about it is really a property of its historical context and the way it's kind of evolved over time. If you think about when it was created, it was really a language to be stuck inside of a document that your document viewer was viewing. So that's crazy if you just think about we made something like Microsoft Word, and then that like displays documents, and then we're going to say, oh, there's a language inside those documents and now we're trying to build applications on top of them. Like that's just like there's a lot in that kind of stack, right? But some of what that particular context when it was created required helped create some things that are weird, some complexities and things that we need to mitigate, but also some things that I think make JavaScript interesting, at least, right? So we have a single-threaded environment. It needed to be fast because you were downloading script from the internet and then running it, right? It needs a very, very quick startup time, parse time. It needs to be dynamic. And so this is kind of a weird one to me, but if you think about error handling in JavaScript, if you throw an exception in JavaScript, your program won't crash. So that's weird if you think about it, but it's good if it's embedded inside of your document in your browser and it's not like locking up the UI and breaking the end user experience. So there's this requirement from UX that says, don't break the experience for the user, and JavaScript's response was like, all right, well, we don't know what to do with errors. Like, we'll just, at the top of the stack, we'll like log a message or something. And then it's kind of up to you to figure it out. Kind of another property of the delivering on the end user experience of the browser embedded JavaScript was that things needed to be quick and responsive, and it was single threaded. You don't want to lock up the UI if you're doing things. If you're clicking around, if you click on a button and you're like, that thing's making a server request and coming back, and it takes 600, 700 milliseconds, you don't want to freeze up the whole thing. You don't want to freeze up their computer. So that's where we get some of this async behavior coming along. So, yeah. Also, kind of like a lot of the funkiness we have to deal with is because Brendan, he likes to say, I only built it in 10 days. Kind of give me a break. So it's missing some things, and some things are really weird. So there's no types, at least not like you would expect in a compiled language. Scoping can be very weird. And then we have some version of object-oriented programming, prototypal inheritance, and that's kind of its own thing. Jacob say that word earlier. But some of these weird things and these weird properties were also inspired by what I think are awesome functional languages like Scheme, Lisp. Fogus's functional JavaScript book is really good to read. So some of the funkiness is just like they're just like we only had 10 days or whatever, like ship it, and now we're stuck with it. So yeah, it is a foot gun. I mean, it can be, but it's one for sure. But it's to me, in my kind of perception of it, it's a foot gun that's made out of materials that you can use to make and mold other things. It's a foot gun that's made out of casting sand, and it lets you experiment and build things with it, or you can just play in the sand and not make stuff with it. Yeah, you get dirty, but whatever. But what's interesting, I think, from the perspective of this talk is, how do you deal with the problems that are inherent to JavaScript in the first place? So, as someone working in JavaScript, I would advise all of you to kind of pay attention to these inherent complexities. And what are the behaviors, the coding practices, and the tools that you use to kind of mitigate those complexities? I've, in the past, have interviewed candidates that had put JavaScript on their resumes, but they actually didn't know JavaScript. They just knew the jQuery API, which isn't quite the same thing. And it's hard if you're only coding to APIs or specific technologies and things like that. You don't actually know what how amazing this is and what it's solving. It's not that useful as much now as I think it used to be. But anytime I think you're using a utility or something like that, or something like jQuery, why are you using it? What does it buy you? Because the answers to those questions kind of raise awareness in you about the complexities that you're kind of mitigating in the environment that you're executing this type of code in. And that's going to apply to other domains as well, not just in the browser and not just in JavaScript. So JavaScript is missing a lot of tooling, and it doesn't really even have a way to deal with packages and stuff. Don't get me started on the ES stuff. But since the solutions to JavaScript's problems are not directly handled by the language, we tend to create a variety of tools to kind of experiment and get the things that we need from the language to build good products. So we're really, really interested in creating software that is stable, predictable, testable, and performant. And some of these tools help us do that, and sometimes they don't. So some of the tools I think that don't work are more interesting to me than the ones that do, because we can kind of look at those and say well, that's an anti-pattern, or that didn't work for me in that case, but it might work for you, kind of in a different place or a different case altogether. So for me, sometimes these tools and constructs that we reach for don't actually work, but it's okay. Some things work out really well. You think about Node.js's startup time, how quick that is, how fast and kind of magical that feels, especially since you don't have to run it through a compiler or anything like that to actually get a server-side application running. And that's kind of a property of some of these limitations and complexities early on in its design. The functional programming aspect of it is awesome to me. And if you think about browsers, some of the inherent space, it's JavaScript kind of, this isn't specific to JavaScript, but the environment of the browser. So you have things like URLs. Apps can just be scripts. There is no app store. Like, you just have to make a GET request for a script, and then the browser executes it for you. That's really great. And then there's a really strong trend or there's a really strong trend for results-driven development in the community at large. So we see tools like Live Reload. Do you folks use Live Reload? Like, see your changes like really quick. I also treat test-driven development as the same kind of thing. Like, we want to see results really quickly. We can write a unit test for that, execute it very fast, and see if the code that we're writing, we get feedback, right away. And these this kind of first principle desires to have this like feedback right away, is not specific to JavaScript. So there are problems, I think, in the space, but it's not what a lot of kind of pedantic computer science folks would say. I think there are a lot of opinions on how to deal with JavaScript's problems and inherent complexities and things like that. But there's some good stuff there too. And like, I kind of think that like this dog's kind of my spirit animal. It's like, I'll just try, I'll download something from NPM and see if it works or not. And yeah, all right. Some of the things out in the JavaScript community, some of the packages and things out there seem insane from the perspective of other languages, like the way we manage dependencies and some other stuff. Left pad always comes up as like a joke. But we learned, not only our community learned from that, but other communities and other package managers also learned from that and kind of defensively design their programs or their package managers in ways to help mitigate situations like that when they come up. And that type of thing never would have come up if a lot of people weren't out there experimenting and using a bunch of small modules in their applications. So in my mind, if someone else provides you with a tool that enables you to spend time on the things that are of value to you, that's a big win. So really, I don't think we have a too many tools and opinions problem. It's just more like things are either useful or they aren't to you at the given time. But sometimes it's a problem. So at some point in time, your tools are going to stop becoming useful to you, or you're going to inherit a project that you don't understand, or is just like on fire, just needs too much love, and you don't have that much to really give. So when we think about abstraction and how we think about abstraction in the way we apply it to the problem spaces that we're working on, how do we know if there's too much abstraction going on? And the only way you would know the answer to that is if you kind of dug into those abstractions themselves and saw what problems they were solving. So like an example of this I'll bring up is, can you use just a shell script that might like grep and pipe something, grep and cat something, instead of using gulp and installing all these dependencies and things, or broccoli or whatever. Or sometimes these abstractions are pushed on us from kind of the outside of the engineering realm. It might be a business need or something that's kind of pushing that thing on there. So when we think about situations like this, technical debt, too much abstraction, I don't understand how this application or this framework works, then really what is our job? How do we put these fires out? What kind of work do we need to do to back a project out of bad abstractions? Do we throw more abstractions on it, or what? So some folks, I've seen in threads and conversations I've had with people, they're like, oh no, like you shouldn't have used this framework. You should have used this framework, or don't use React, use Chew or whatever. And the framework isn't as important if you think about in the terms of like cross-discipline work and managing complexity. Frameworks don't really matter that much. The ability to evaluate a framework and how it applies to your problem space, that's what really, really matters. So when we look, I like to look at frameworks. I like to look at their dependencies and see what they're doing. I like to see the tools that they're using. So we can think about, when we think of abstractions or frameworks or things, and we kind of see what they're doing or what they're affording us, You can take a peek at their package JSON and see what's going on in there. Maybe dive into their code a little bit. You don't have to like understand it and study it, but you can say like, oh, this thing abstracts a DOM in this way, or this actually uses virtual DOM under the hood. Like, we could just use that package instead of like having all this extra stuff we don't need. So think about the tools that we use and what are the tools that they use to create solutions to the problems they're trying to approach. So what are their dependencies? How do they use them? And is this a thing I can use? Are their dependencies, can their dependencies become my dependencies without absorbing the cost of their abstraction or their technical debt or their like opinions that just don't, might not apply to your application or your problem space? So I would recommend, and this is something that's worked out well for me, and it's just kind of, it's like advice, right? Like you just don't, it's just my experience, so like you don't have to take it. It probably might not apply to you at all. But I would say, working in your day-to-day work, doing things in JavaScript, I recommend digging into the things your code is built on, finding out what things they're solving for you, if they're solving anything. I've done this on a few projects and dug into those things, and I'm like, dude, we're using this giant abstraction and like downloading like 50 kilobytes of like minified code for like 2 for each functions. Like, it's just write a for loop, right? And if you don't know how to do that or it's too hard, it's pretty easy to find out. So don't think about coding to APIs or frameworks, but learn what they're actually doing for you and why. And if you don't really know why, work on maybe developing the language to find the answers. So you don't need to know the answer, but you need to kind of know enough about the domain space that they're in to be able to maybe Google it or whatever. So discover how your tools work and what methods they use to help you manage the complexity that you're working in. So this is more of a kind of mental reframing for me, but it was a little bit of a revelation because when I started working in other languages, I noticed, I was like, hey, this is just like a problem I had done in JavaScript or like had done a long time ago. I was like, I know how to do this without making 3 extra loops and all kinds of stuff that you might run into. So I think there's a unique set of skills that a lot of us are already exercising. We just might not be conscious about it. And these skills can be applied beyond JavaScript and web development. And as a community, we've developed a lot of tools and methodologies for negotiating complexity in changing systems, right? Browsers change all the time. And our applications break as just like a matter of course over time, and we need to kind of adapt to those. And things like jQuery, kind of help with that. Sometimes you just have to upgrade it and like it works. Sometimes it's a little more involved than that. So we have methodologies for negotiating a complexity, how to build robust applications in error-prone environments. The browser is a really, really error-prone environment. Like users could be doing all kinds of crazy stuff. The browser's doing stuff. There's all kinds of weird APIs that if you don't interact with them in the right way, yeah, who knows? IndexedDB is like a kind of difficult thing to wrangle errors in if you've ever messed with that. And we are JavaScript. The JavaScript community is constantly kind of adapting to a new and constantly evolving application environment, not just in the browser, but on mobile, in microservices, on the servers, in robotics, in embedded devices, IoT devices, and things like that. So there's a bunch of things we can kind of explore with just a little bit of kind of JavaScript knowledge and just kind of asking the right questions as we kind of step through this. So when I think about first principles in JavaScript and how they kind of apply to my work in other languages when they pop up, I have a really short list here. It is single responsibilities. You have code that kind of does one thing and does one thing well. No side effects. That means you're not mutating global state. You're not mutating things in other spaces. This is really hard in CSS. Negotiating this in CSS is a very, very special skill. Yeah, big ups to anyone who has to do that for work. It's hard. Results-driven development. So like I was saying, test-driven development, live reload, seeing the results of your actions and your development effort kind of right away. It feels really good, but it also tells you like, hey, the thing you did actually works. Keep doing it, or it didn't work, and keep doing it until it does. And then making sure that our software is stable and predictable. So all the things I just listed, like that's not specific. to JavaScript in any way. That applies to any software discipline. And I would say that it even applies to some aspects of user experience and product development kind of generally. And there is, like I was talking about NPM earlier and dependencies and jumping into stuff. There's a lot of diversity there to kind of dive in and explore. There's also a lot of crazy stuff, but sometimes that tells you, you can kind of see what like an author or package author was getting at. You know, you get a sense of like, oh, they were trying to solve this particular problem. They might not have done it very well, but they're like really close. And if they just did it this way, where you could fork those projects and kind of dig into it yourself, or it just informs you like later when you see that pattern, you're like, whoa, we're not gonna do that. To become a unicorn. So when I say unicorn, you know, I mean you folks. I mean JavaScript hackers. You know, just ask why. Like, why does this thing exist? Why am I using this tool? What is it helping me do? Understand why, or at least get enough language to be able to search it and find it on Stack Overflow or in a book or Google, or there's tons of articles out there that can help with this. And really explore kind of what excites you, because like I was describing before, there's this really large application space where once you know enough, you can jump into. If robotics is exciting to you, you can go and do that. If embedded systems like IoT stuff is exciting to you, all the tools are there. Everything's on NPM. You can start playing with it, and it actually kind of can feed back into your day-to-day work. Like, you get better at doing this stuff the more you kind of exposed to it. So yeah, and this, don't be boring. That just kind of goes into the hacker thing. Like, hackers are generally very excited. If you're not excited, just don't. You know, I'm not saying like don't do JavaScript development, but I'm saying if you're not excited about doing browser development, but you like coding in JavaScript, then you know, dig into the server-side stuff or whatever. There's lots of places for folks to go and kind of explore, both as a hobby and maybe even as a kind of a career path, or opening up career paths for you. So yeah, that's all I have. Sorry, it's a little jumpy, but yeah.